Hello and welcome to Profiles. I'm Ed Highland, and today we're going to look at the one thing that Central Floridians seem to talk about almost as much as the weather, and that's traffic. Our guest today is Dr. Essam Radwan. Since 1998, Dr. Radwan has been the Executive Director of the Center for Advanced Transportation Systems Simulation, or CATTS, located at the University of Central Florida. He has conducted research in numerous transportation applications and has been working on pretty much everything from traffic flows on Interstate 4 to new ways to get people to stop at red lights. Welcome. Thanks so much for coming by and joining us today.
Thank you very much, Ed. It's a pleasure to be here.
You know, it seems that folks are talking about it all the time, and we have so many cars on the roads in Central Florida that it doesn't seem like we have enough roads, that we can ever keep up with the number of cars out there.
Well, first of all, Central Florida is a hot spot. It's a growing area. The economy is growing. And the signs of a growth economy is building roads. And the more you build them, the more people will come.
Now, if we are in a situation where we have a lot of cars and not enough roads, or we just are having trouble keeping up with that growth, obviously one of the best ways to handle that is trying to manage those cars somehow. And you've been working on some study work with Interstate 4. Kind of give us some background on how you got started in that and where you're drawing your research work from.
Well, essentially there were a couple of projects. One that involved District 5, where we wanted to do some kind of a data clearing warehouse at UCF, where we keep track of all the traffic on I-4 through the loop detectors. Those loop detectors are wires in the pavement on I-4, and what they do is they count cars, they get the speed, and they give us some kind of an instant picture of how busy I-4 is. So we managed to build a fiber optics that transmit all that data to UCF. And it's heaven for research. You got plenty of data, you can analyze it the way you want, you can do research on how to improve the operation on I-4.
Now, if we can stop just for a second and talk a little bit about the loops themselves. Are they similar to what a lot of folks are familiar with like at a stoplight, you pull up and there's some type of a detector there?
Right. They're very similar to that. Different type of loops because they do a different function, but it's the same concept. A car is there, it can count them, it will know that they're there. If they leave, the loop will says there's no more cars.
And how does it determine how fast the car is going at that time?
Well, there are two loops. And they're very close to each other. So you pass over the first loop, it knows that you passed there, and then when it gets to the second one, it determines how fast you got from the first to the second one, so it can get the speed. And at the same time, it will know if there is an accident. If the loop has the car on top of it for an extended period, you can interpret it two ways. One is either there's a queue because of regular congestion, or an accident that resulted in a queue that occupied the loop for an extended period. So that's where we use a little bit of engineering judgment and couple with the cameras. So you can use the cameras in addition to the loop to know whether it's what we call recurring congestion, the daily congestion, or an incident.
So you correlate, those are the cameras that we see on many of the news stations and such, and you correlate that with the data coming from the loops themselves.
Correct.
Okay, well, an average driver might say, well, I'm on the road, I see how fast everybody's going because I know how fast I'm going. I see the accidents. How can you take and extrapolate that data into something that may help us regulate that flow?
Well, if you get some kind of a pattern, and if you know that with this kind of traffic you predict that many type of accidents, perhaps you will try to find ways to regulate the amount of traffic getting on the freeway. Although we haven't implemented one of those, sometimes you put a traffic light on the on-ramps, so you regulate the amount of traffic getting in. That might control a little bit of traffic and minimize accidents. The other important thing is if you predict an accident using those cameras, you send help as soon as possible. And you see some of those trucks running around, they provide service that is fast, because the faster you remove the disabled car, the better the traffic is going to flow. So those cameras are used also to predict and help out with emergencies on the freeway.
Now you use the term predict. As I understand it, you're actually getting to a point where you have some areas that you can pinpoint as most likely to be an accident zone?
Exactly.
How does that work?
Well, that's part of the research we do. For example, if you look at the pattern of traffic in the last 4 or 6 months, and areas that are known to be vulnerable and always have queues, then you know that they either have some operation problems because of the amount of traffic getting on and off, or maybe design problems. The design problems sometimes are hard. Like I can tell you on I-4, the Ivanhoe curve always have a problem. And any time in the morning you find a queue up, it's on Ivanhoe there at that curve. Why? Because the speed limit is 50 miles per hour. The lanes are narrow. What are you going to do about that? If you can widen I-4 at this location, more power to you. You may not have that luxury because of the right-of-way. But at least if you find ways to control the amount of traffic getting in and leaving, that might be a good solution to it. And these are hard solutions sometimes.
There was a recent proposal floated that talked about the concept of using some type of a toll lane or a high-speed lane. Is this something that would be a workable object for traffic control, or is?
Well, yes and no. These are the Lexus lanes, right?
Yes.
Where you charge people on I-4.
And the price goes up depending on how much traffic there is.
Exactly. I mean, anytime you charge for using the road, definitely you will reduce the demand. That means less people will use the road. But on the other hand, you'll be surprised. The toll roads in Central Florida are very busy. People are willing to pay. Now, you get to the point we say there's an equity issue here. I-4 was built with the assumption that everybody would have a free ride. Now, you put lanes there and you're charging. I don't know if really you address that equity issue or not. I am of the opinion that if you can find an alternate road parallel to that and make it all toll, I think you'll probably get a better perception of the motorist. And you probably need it to go all the way north-south, starting from Lake Mary, maybe going all the way to Disney.
Well, that's been talked about the last 20 years or so,
right.
and politically it's been very difficult for anyone to come to consensus on that, so it just
right.
hasn't happened. We've got, what, a three-quarter loop, basically,
right.
around Central Florida.
Yeah.
I wanted to talk a little bit more about, before we leave the interstate issue, the potential or the idea of using some type of traffic control lights, a stoplight or something, on the on-ramps. I've seen that used very effectively in Texas, in
Minnesota,
in Colorado. Many states have them.
Yes.
But yet it seems that we've shunned away from that idea. Are our on-ramps not long enough to do something like that? Why is that such a controversial issue?
Well, I think it's doable. I think, again, it gets to the point where it becomes an equity issue. Equity in the sense that I'm on I-4, why do I have the privilege over somebody else who wants to get on, and the person who wants to get on is denied that privilege. But anytime I think of technical solutions, it's doable. You'll find a way to make it happen. It's usually political issues that stop things from happening.
I didn't know if there was a law in Florida that prevented something like that.
I don't believe so.
Seems like they could do a test, you know, to have a couple of on-ramps or something with a few lights just to see how it works.
Sure, no, I think it's doable and it can be implemented. Same thing with those HOV lanes, high occupancy vehicle lanes. They have been used in other places in the country. They've worked fairly well. The challenge with that is to enforce them, to make sure that, you know, people are not violating them and stop them and give them tickets for violating that.
Well, those lanes have been there since, what, the 70s, I think? It was a
Right.
Carter administration or something
Right.
to save gas initially.
Right, right.
So they have been in place. There just hasn't been, as you say, the enforcement aspect.
Yeah. But at the end of the day, you build roads, they get busy, they get full. You've got to find other alternatives mode of transportation. You got to look and think in terms of rail, high-speed rail, commuter rail, bike lanes, transit buses, and you have to bite the bullet and spend some money on that. You can't just keep building roads. Got to find alternatives.
Have your studies indicated any potential benefit to using, say, a sign or a warning device? Talk about Ivanhoe, that curve in there, which is, I think, most people consider an engineering nightmare anyway.
Sure.
But if some kind of a warning sign or the signs that are up there now give you some warning of an accident, but additional signs or additional information that may or may not control people's behavior? And
definitely there has been a lot of research on that. As a matter of fact, Florida DOT has just issued a research call for research proposals to look at what they call the dynamic message signs. These are the signs that you put on I-4. You feed in information real time about a potential accident in the next 5 miles, but you have to find an alternative. The alternative here is if you exit now, you've got to find another way to get to where you want to go. And sometimes you're stuck there. There's no alternative. But they have been proven to work efficiently if there are alternatives and if somebody there in the control room feeding in the information real time, credible information, because you have to have credibility. If you're driving on I-4 and you see some information there and it proved to be false or wrong, then you're not going to look at it anymore.
Yeah. You don't even get two chances with
exactly.
that kind of thing. Well, let's talk a little bit about the red light issue. Obviously, it has grown in recent years as more and more people are on the road. We've had some terribly tragic accidents involving red lights that apparently were run by drivers. What kind of work have you been doing with the red lights? And I know, let's talk about the simulator a little bit, because that's a fascinating part of what you do.
Right. We were very fortunate that part of our transportation center is housing a couple of simulators. And the idea there is we have a driving simulator that has an interchangeable cab. You can put a passenger car or a tractor-trailer cab. Currently we have the sedan. It's a Saturn car. There is a motion base that moves in 6 degrees of freedom, so it gives you the feels of the bumps of the road. And we can generate any scenario in that simulator. Freeways, traffic lights, toll roads, rain, snow, sunshine. And we thought that maybe by designing a little experiment and trying to test that and see how the motorists understand it, this particular experiment, it might help us to reduce red light running. The concept here is to paint on the pavement a message that says signal ahead. And if you're on top of that painting and the signal turned yellow, you have the option of either stop safely or continue at the posted speed. If you're behind it, you should stop. If you're ahead of it and closer to the intersection, you should keep going. So it's some kind of a guidance to the motorist saying that, here we go, help out to either continue or stop. So we put that in the simulator, and we brought about 40 subjects, male, female, young, middle age, and we wanted to test how they're going to react to this particular design. And we've collected the data and found out that this particular marking helps to reduce red light running.
Now, and you base it as far as its position on the speed limit, I assume.
Exactly.
Oh, okay.
The speed limit and also how long the amber period is. The yellow part, 3 seconds, 4 seconds.
Now, is there a concern that it's gotten to a point where people kind of ignore yellow lights, it would seem? Right. So does it become a marker that perhaps would be utilized initially, and then people would say, oh, well, you know, I know better than the marker, or the speed's different or something?
Yeah, that's another thing, is if it's not dynamic, then people will start ignoring it after a while. But perhaps if you can complement that with some kind of a counter, a small counter on the side there, where you go 5, 4, 3, 2, 1 electronically, like a clock, that tells you that this is how much time left in the amber phase, or how much time left in the green before the amber starts. Maybe you can complement that with the marking, and that will help the motorists get some cue about where they are. Part of the red light running is not only being in the right place and do it properly. Part of it is the attitude of the driver about red lights and yellow lights. And we found out that some people just don't stop, whether it's yellow or red. They just keep going. They just have that kind of attitude.
Those are the ones you got to watch out for.
That's the one that should be ticketed.
And then there's the other folks, unfortunately, with our today's society, you know, cell phones, beepers, distractions that are there. The other passenger may be.
Exactly.
It becomes just another visual or oral stimulation that's out there that potentially could disrupt your driving ability.
I had the privilege of spending a semester on my sabbatical last spring, and I did visit Sydney, Australia. That was part of my sabbatical. And it's a different type of environment, different culture there. Maybe a little bit stronger government than what we have here. They use a lot of red light cameras, red light running cameras, and they enforce it very well. And if you get a ticket, even if you go to court and challenge it, they throw it away, and I mean throw it out of court, and you have to pay it. So I looked at the crash rate in Australia, and the fatality rates, the number of people died there, it's half of what we have here in this country.
Now that's a pretty staggering statistic.
It really is. It really is. And so they take it seriously, and they enforce the law, and they educate people about what it means running red lights.
Speaking of education, is that a part of, I don't know if this was included in your sabbatical or not, but is that a part of the process to obtaining a license? We have, you know, tests that our teenagers have to pass, and it would seem, I mean, how many times have you been in a car and said, you know, where did you get your driver's license? You're ignoring some basic rules there. That's right. So do they have a more stringent early education program?
Very much so. In Australia and in Europe, they're very stringent. And not only that, but here in high school, particularly in Florida, with a large number of students in high school, the driving education courses used to be offered with a test track and people go out there and drive. You don't see that anymore.
It's all been cut back, yes.
Exactly. So
yeah, when my daughter was getting her license, I said, don't you have to take a driving test? We don't have a car. I mean,
See?
when I was a
There you
kid,
go.
we had a car. I mean,
Right,
to go out and, of course, our simulators were a little different back then than what you have now.
right.
What else can you learn from the simulator about the driver's habits? I assume you're not only finding out what works on the road, but you're also learning a little bit about the people, the folks who actually get behind the wheel.
That's true. Well, first of all, you can look at the age difference, the gender difference. We haven't gotten into the elder driver physical characteristics, for example. That's a completely different ballgame. But at the Institute for Simulation and Training, they've been doing some work on training commercial drivers. What's commercial driver's licensing?
Truck drivers.
The
that
truck
sort of thing,
drivers
sure.
and the kind of test that they have to go through to be able to drive carefully on the road, handle the truck very carefully if there is a problem with the truck, how they fix it, and provide public safety. And so training is important, is another important aspect of simulators.
Are you also finding anything that would be of benefit to the car manufacturers, perhaps devices or methodologies of designing dashboards and such, or brake pedals that may help them help us become better drivers?
We have a project right now, a couple of faculty in electrical and computer engineering. It's funded through DOT, and it's looking at those technologies that are being put on board more often now than before. Like the map that guides you through the system.
Yeah. My dad's got one of those that talks to him, tells him where to go.
Yeah. So and then possibly cellular phones and other gadgets that we see more of in our car now, and how it impacts the driving behavior. Because if in fact these things are going to become standard in the next 10 years in our cars, we ought to be A, comfortable with, B, know that they work well and they're not going to jeopardize our safety. So we're doing some studies on that, and we want to make sure that the manufacturer industry, the car manufacturing are aware of the findings of these studies.
Yeah, it would seem if you could paint a line on the road that says prepare to stop, then some of the devices that are there, which do have a verbal type of message, it seems like you would just have a little transmitter there. It says there's a light here, it's turning red, prepare to stop. It just gives you that warning.
You're absolutely right, and that's real time. And here, if you can find a transmitter at every signal that tells you 4-second amber, or you're too close or too far away, perfect, more power to you. But the drivers have to A, become familiar with that system, how they react to it, so we have to test some of that. And the driver simulators could be a good place for that.
So where are we? I mean, what can we do at this point? I mean, you're working behind the scenes, so to speak, trying to put together some studies and feed some information in, but you can only do so much in terms of presenting the data. It actually has to be acted on at some point.
And that's where Florida DOT look at our projects, and at the end they say, okay, well, how much of that can be implemented? So there's an implementation component. If in fact we come up with a product and we've tested in the simulator, then maybe DOT will come in and say, okay, let's design some standards here and let's send it to the feds. And if in fact becomes effective, then maybe be implemented in some regions.
How about speed limits? That's one thing that it always seems to come up in conversation. A, if you can get to the speed limit, which is sometimes difficult on the roads, but are we at a point where it just might be a wise thing to do to say, okay, we have too many cars, and these are big cars, they're dangerous, they're weapons. Should we be going a little slower, have the higher speeds on the toll roads or the roads that aren't quite as congested?
I think speed limit is very important because, again, the major cause of a lot of fatalities is speeding. And if the road is congestion, you don't have to worry about getting to the speed limit. What you worry about is the off-peak times in rural areas where people are exceeding the speed and where you have a differential in the speed. Somebody is going the speed limit or a little bit lower and somebody is way exceeding the speed limit. That speed differential would result in a major crash, and the speed difference will result in much higher impact. The other issue of the difference in the size, you've got trucks, the big rigs with tractor trailers, you've got the SUVs which are much heavier than before, and you've got the regular sedans. And the mix of traffic there is also dangerous because the inertia of one car is different than another. The impact is much more apparent there.
I'm jumping around a little bit here, but getting back to the simulator for a second, you mentioned that there are two cabs basically which can be put on it. Did, when you were doing the red light studies and such, did you utilize the truck cab as well, or just the car vehicle?
We focused on the car vehicle. Okay. There's another study that we're doing, Ed, and it's also a complement to the red light running, which is following light truck vehicles, the SUVs and some of the medium-sized trucks. To me, it's a black box. The glass are tinted, they're higher, you can't see around them, right? Yes. So you rely on the brake lights if you're following too close. So we're doing a little study there to see how fast people stop if the car ahead of them is a large-sized truck. So that's the horizontal obstruction of view. There's also those trucks that are very high. When you get to the traffic light, you can't see the signal head. So that's another study that
How
we're
many
doing.
times have you been behind a vehicle and you're going, okay, is the
is
light
it
red?
light?
Is,
exactly.
Do I have time?
Right.
And you have to adjust your speed accordingly.
Right. So we're doing part of that using the simulator too.
Are you telling us the bottom line is just be careful out there?
That's right.
I mean, is that pretty
just
much
be
where
careful, yeah. Keep your eyes open and ears down to the ground.
We're jumping once again. I wanted to get back into I-4 just for a second because I mentioned the toll lanes that they're considering, and apparently that's not going to really fly too well with as you say, the free concept of I-4. But construction is going to happen, and I-4 is slated for a major facelift along the way.
Sure.
Has there been talk, consideration, study potential for what's going to happen to this incredibly fast-growing community when you start shutting down lanes on its main thoroughfare?
I know that one of my students she's going to be doing her master's degree on this particular issue. She works for Florida DOT, and she's been involved with the construction of I-4, and she picked that as a topic for her thesis. So she's looking at 3 different ways of blocking the road for maintenance and construction, and how it impacts the queue buildup and the potential delays, the excessive amount of delays. So we're doing some studies on that, and at the end of the day, we're going to have to live with all these delays, believe it or not, because there's no other alternative.
It seems like that's where you might want to talk about putting some of those stoplights on the on-ramps because we're going to have the
control
construction,
the amount of traffic
try and control what's going to be on the side, because I think
Exactly.
they begin on the side work and then kind of work their way in from that point.
Exactly. You've got to find other ways to reduce the demand there.
Have the cameras, we see them in traffic reports, as I mentioned earlier, on most of the local news stations. Is this something that you're watching very closely? Are you talking to the DOT about putting in perhaps more cameras? Would it help to have more cameras in more locations in terms of studying and helping us with this traffic flow?
I think you get to the point where too many cameras are not going to do much anymore. I think right now with what they have, it's sufficient, the number of cameras on I-4. The Expressway Authority and the toll roads, they've been all retrofitted with cameras, and it's good that they're doing that too, because it's all one big network. Whether you're on 408 or 417 or I-4, you go from one to the other. So, and then the 2 authorities ought to talk. The Florida DOT District 5, which controls I-4, and the OOCEA, which controls 408. And I think we're getting now to the point where they're sharing information and they have to work together. Now, does that feed back again to us at UCF to do research? Well, it hasn't happened that often that we hope to, but occasionally they contact us if there's a question on issues that pertains to some theories or some work that we can help with.
Well, with the 408 essentially, coming right into the university property, it would seem that would be a perfect link along the way.
Right.
And so they won't be sharing, if they were to expand the network, they wouldn't necessarily be sharing that same optical link.
The fiber optic thing. No, probably not. Probably not, yeah.
Well, I want to appreciate you for coming by and telling us
much.
all about this. It's something that we are far too familiar with, I'm afraid, as far as the traffic goes. Now, if we can work on Alleviate Trail and University, do you get into some of the neighborhoods as well?
We do. We do some work on the city streets and the arterials because they're equally important. If you don't have a good street system down there, then you've got some problems. Actually, one of my students did his PhD, and he's going to be defending soon on the concept of cars leaving the freeway and then getting on the city street, and they do what we call the weaving. They cross this lane and this cross that way.
Cross 3 lanes.
Exactly. All of a sudden you have to cross 3 lanes to make a left turn. And so what is that distance that you have to provide there to make that safely? So he's done his dissertation on that, collected data, and he's going to be defending soon.
And so that may or may not give us some ideas about, you know, perhaps
how long
extending the road a little bit or changing the shape of the off-ramp.
A different design for the off-ramp, exactly.
So potentially what you and some of the students are working on are reconfigurations of the way these roads look to give us some more time and maybe a little more margin of safety.
That's correct.
We'll look forward to that as well.
Thank you very much, Ed.
Dr. Essam Radwan, thank you once again for coming by and sharing your insights with us.
Thank you very much. It's a pleasure to be here.
And that does it for another Profiles. Wanted to thank you so much for joining us. I'm Ed Highland. We'll see you next time.